Good afternoon, class. In today's video, what I'd like to do is to talk about atomic structure. And to start off with, I need to do is to talk about the four fundamental forces of nature, which are the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. So in order to really understand why they're important, I decided to underline the two that are most important to our discussion, which is the electromagnetic force and the strong nuclear force. And the reason I do that is because there are several vocabulary words that we have to go through, like nucleus, electron cloud, orbitals, and valence electrons. I will define them as we go through this video, and then of course bonds and the octet rule. So we'll talk about those. So in order to do that, but I needed to have the fundamental forces stated and down pat first, because if I didn't have that, then all of this wouldn't necessarily make sense. Now, the next part is I am trying to draw something here, so please excuse my my lack of artistic skills, like I said in previous videos. But here we go. We've got an atom over here, and the nucleus is this middle part right here, the very center of the atom, and I drew it in blue because they relate to the strong nuclear force. Okay, because according to the electromagnetic force, which these electrons are actually following right here, they're supposed to repel. All charged particles, if they are the same charge, they're supposed to repel each other. Kind of like what you learned in elementary school. However, so what happens here is the electrons, they very much follow this. They stay as far apart as possible. But they are attracted to the positively charged protons in the middle. So in this case, this works well. These electrons are following the electromagnetic force primarily, and so they're good to go. These protons, on the other hand, don't seem to be following the electromagnetic force. They seem to be following something quite different. And the answer is they're following the strong nuclear force. Because when you force protons to get close enough together, eventually what happens is that the strong force, because it's way stronger than the electromagnetic force, but only over small distances. So if you force the protons together close enough, they will actually stick together and not come apart. That's what creates a nucleus like this, where all the protons are super close to each other and the electrons are kind of hovering away from them. So that's what makes the nucleus of an atom. That actually is the basic structure of an atom right here. Now, of course, that includes things like the electron cloud, which is all it is just the place where the electrons are. One thing that has to be made clear, what I drew here is not entirely accurate, and the reason it's not entirely accurate is because these electrons are drawn as if they are floating in space in this position. However, that's actually not true. And even if somebody said, oh, but it's because they're moving, that's actually not true either. It's because you actually don't know where any of these electrons are. They could be here, they could be right there on the camera, they could be on Mars. It's just that there is a probability of where that electron is, and the most likely place for the electron to be found, if you were to try and measure it, would be over here. That's the highest probability, because you can't know where anything is at this atomic scale because of quantum mechanics. I can get into that in a little bit in a future video, possibly with the Heisenberg uncertainty principle. But for now, we'll just say you can't know exactly where it is or what speed it's going at with 100% certainty. So the most likely place is right here, but it could be over here or over here. Could be hanging out inside of the nucleus. Those are very small probabilities, but non-zero. That's why I say them. So that's what the electron cloud is. Now we move on to orbitals. What are those? They are levels of how close electrons can be. So you have to understand something. Electrons want to be at the lowest energy level that they can be, but due to quantum mechanical rules, you can only have so many at this lowest level. And in this case, for this atom, there are only two that can fit at that smallest level, that lowest level of electron. That's the bottom, and that's where all the electrons want to be. The next level above that, they will tolerate, because it's as close as they're going to get. So that's where the second level of electrons is, and that's why they're called orbitals, because they're places orbiting that are around the nucleus that have a high probability of them being there. Along with that comes the concept of valence electrons. And what are those? Because valence doesn't really tell us much, especially from our everyday usage. But what a valence electron is, very simply, is the electron on the outermost set of electrons on an atom. So in this case, it's these 8 that are on the outside that are the most important. Okay, those are the valence electrons. And for all of you chemistry people, that is where all chemical reactions take place, right here at the valence. If you've got the inner electrons, they don't really participate, except in very rare cases would you ever have a chemical reaction due to inner electrons. It's almost always on the outside of the electron, unless something absolutely strange is going on. That doesn't happen. So that's what a valence electron is. And so now that we've talked about the structure of one atom, now let's talk about what happens when you've got multiple atoms coming together to form what we call chemical bonds. Now, of course, what is a chemical bond? A chemical bond is when atoms share valence electrons. That's actually where chemical reactions, and that's why I said chemical reactions take place over there, because these atoms are now forming bonds or splitting bonds. And so they will share a lot of times what will happen is you'll have something share its valence electrons with another atom, mostly because atoms are complete, and they want to be complete based on what's called the octet rule. The number of valence electrons in an atom is 8. That's the most that it wants in its outer shell. So in order to fulfill that, that's what the motivation for pretty much every atom and all of the chemical reactions and chemical bonds that are formed within any set of atoms, especially this one, which is 2 hydrogens and an oxygen, H2O, which is also water. What they do is the hydrogen atoms get something out of this chemical reaction, because they have one blue, and this is a blue dot. This dot represents an electron. So they have one electron, but they get to share an electron with the oxygen. So that makes them happy, because their valence electrons are only in that are filled when it's got 2, because that's the first set, like this one over here. The first inner level is 2. So for hydrogen, it can only take 2 in its set of within its orbital or its valence electrons. So it can only have 2. So that's why it's a happy arrangement over here. Same with this hydrogen, and this oxygen gets to share the one electron from each of the hydrogens. So now it has 8 because it starts off with 1, 2, 3, 4, 5, 6 green or its own electrons. That's why I colored them in green, and it shares the blue electrons with the hydrogens to give it a total of 8. So now everyone feels like the hydrogen has 2, this hydrogen has 2, and this oxygen atom has 8. So everyone is happy. Everyone is obeying the octet rule. So that's how the atoms are formed. That's how they are. That's why they are structured the way they are. And what I can do in future videos is talk about what happens when, based on the motivation of all of the atoms, because this octet rule is very powerful, and it actually drives the different types of chemical bonds that exist within chemistry and within, of course, physics, because physics is the basis of chemistry. So that's how atomic structure goes. And so that concludes this video on atomic structure. Good luck in your studies. May the force be with you.